Welcome back, everyone. Today we are going to be proving this Pythagorean identity here, that cosecant squared theta is equal to 1 plus cotangent squared theta. So let's dive in. All right, so what we're going to do first is just review what we know about Pythagoras' theorem. So Pythagoras' theorem states that a squared plus b squared is equal to c squared, where A and B are the legs of a right angled triangle and C is the hypotenuse. So in this particular situation here, we have that A squared plus B squared is equal to 1 squared, since in this example to our right, A and B are the legs and 1 is our hypotenuse. So that means that A squared plus B squared would just be equal to 1, right? Since 1 squared is just 1. Next, we need to figure out how to, instead of writing A and B, or A squared and B squared rather, how we can write cosecant and cotangent. So first of all, what are cosecant and cotangent exactly? Well, cosecant is 1 over sine theta, so that's where I'm going to start actually, by figuring out what sine theta is equal to. So sine theta is equal to opposite over hypotenuse, which is going to be B over 1, which is just B. So therefore, B is equal to sine theta. So there we go. And then what about cotangent theta? Well, cotangent theta is just the inverse of tangent theta. And tangent theta is equal to the opposite over the adjacent. So B over A in this case. So there we go. And then what I'm actually going to do is I'm going to swap A and tangent theta and say, okay, well, A is equal to B over tangent theta. And then we can do another swap because we know B is equal to sine theta already. So A is equal to sine theta, since sine theta is B over tan theta. So there we go. All right, so now I'm going to sub in this value for A and this value for B into the A squared plus B squared equals 1. And then we're going to simplify that as much as we can in order to end up getting cosecant squared theta is equal to 1 plus cotangent squared theta. So therefore, sine theta over tan theta squared, so that's A squared, plus B squared, which that's going to be sine theta squared, is equal to 1. Therefore, that means that sine squared theta over tan squared theta plus sine squared theta is equal to 1. Then I can actually factor out just common factor out a sine squared theta. So sine squared theta is equal to 1 over, or sorry, not is equal to, times 1 over tangent squared theta plus 1 is equal to 1. Then if I divide both sides by sine squared theta, I will get, on this side, 1 over sine squared theta. And then over here, I'm going to get sine squared theta over sine squared theta, since in this step, I'm dividing both by sine squared theta, times 1 over tan squared theta plus 1, like that. And then these, of course, cancel. And then all I need to do is just remind myself that 1 over tan squared theta is the same as cotangent squared theta. So cotangent theta plus 1 is equal to 1 over sine squared theta. And just a reminder, 1 over sine squared theta is just cosecant squared theta. And so there we go. If we look back, we do indeed have this identity here. I suppose it's written in a different order, but we can just change the order. Cosecant squared theta is indeed equal to 1 plus cotangent squared theta. So there we go. All right, any questions? Feel free to leave those in the comment section, and we'll see you for the next one.